Hey, physics fans, welcome back. And here we go with this number 28 off of the WaxOn WaxOff worksheets. A toy car is traveling south at 7 meters per second and starts to accelerate north at 2 meters per second squared. At what times, there's a plural there because there's more than one answer. That's why I put it there to emphasize it. Will the car be at 10 meters south from where it started to accelerate? There will be two times. This question can be solved for final velocities first and then use it in the process to calculate the times. So there's lots there, there's lots of hints there and stuff like that. I'm trying to avoid the quadratic equation. Okay? Trying to avoid it, so that's why I'm giving you the last sentence there. Solve using the final velocities first. What makes this an advanced question is we've added vectors in here. And they're vectors that are in the opposite direction. So we're doing a north and a south here, and accelerates north. Okay, so the direction of acceleration is north, but it starts going south. VI is south. So it's going to be slowing down. We have to choose a positive and negative in here because our kinematic formulas that we have, okay, and one of the ones that we'll be using will be like VF squared equals VI squared plus 2AD. The A and the D are vectors, and it's one-dimensional. But to use a number in here, we can't just say north and multiply it. We have to put positive or negative into these formulas. So we have to choose positive or negative. And I always try to do positive for the acceleration. That's just me. But whatever you do, you notify the marker, you notify yourself what you're choosing to be positive. Therefore, the initial velocity will be 7 meters per second. That'll be a negative. Okay, because that's the opposite of it. And that's what all we have to do is choose the directions as positive. And that's what makes this a challenging question. That's all. Choosing our north and south and make it known that we're going to do it. So if we were in an advanced class, we would say north is positive. You state it clearly what you're doing. Okay, so let's now write down the beginning stuff. The toy car is traveling south, so the initial speed is 7 meters per second south. But if you really want to jump into our nomenclature of our numbers, this is going to be negative 7 meters per second. The acceleration is 2 meters per second squared, and that's north. And using our, that's going to be positive 2 meters per second squared. Now it says, at what times will the car be 10 meters south? So the displacement that we're talking about here is 10 meters, whoops, not a small m, 10 meters south. And that is going to be negative 10 meters. Okay, we have the vector format of it here, and I put it into the numerical with positive and negatives, so I put these numbers into the formulas. Because you can't put south in there, because then what's south squared, right? So we now plug these into the formula. What are we trying to solve for? We're trying to find velocities. Why are we trying to find velocity? Even though it says what times, it says, hint, find the velocities first. If you know the quadratic equation, you can throw that in there, but I'm not teaching it that way. Okay, so VF squared is equal to VI squared plus 2AD. So VF squared is equal to VI squared. VI is negative 7. So negative 7 all squared plus 2 times A is positive 2 and D is negative 10. So we get positive 49 here. That's what negative 7 squared is. And this is going to be negative 40. So this is going to be VF squared is equal to 9. So we get VF is equal to plus or minus 3. The next step here, find out for both of these answers what the times are. So we're going to do it for time is equal to, oops. Pay attention, Mr. Curl. VF is equal to positive 3, and then we're going to do it again for VF is equal to negative 3. And we're solving for time at this point. So we have VI is negative 7. We have A is positive 2. We have D is negative 10. So we want to solve for time. Which formula did we use? There's a few now because we have 4 obviously to solve for time. I'm going to use this formula. Acceleration is final velocity minus initial velocity over time. Rearranging that, I'm going to get time is equal to VF minus VI all over A. So time is going to equal positive 3 minus a negative 7 all over an acceleration of positive 2. This is going to be 10 over 2. So time here is going to equal 5 seconds. And we're going to copy all this stuff over because we're going to do the exact same thing again. I should have probably copied more. Down here then. Okay, fine. Same initial acceleration. Doing it the same way. I'm going to do it in black this time. T is equal to VF minus VI all over T. Negative 3 minus a negative 7 all over 2. And what's that going to equal? That's going to be negative 3 plus 4 plus 7 is going to be 4 over 2. So the time is going to equal 2 seconds. We get 2 answers. Why do we get 2 answers? You're going at 7 meters per second. Okay, let's just take a look at what it kind of looks at. We're going to start here. And after 1 second, you're going to be 7 meters per second south, but your velocity is going to be only 5 because you're changing by 2. So actually, maybe a chart would be better. Let's just zoom this out a tiny bit. We have your location and your velocities and your times. So at time 0, your velocity is negative 7. And then at time 1, it'll be negative 5. At time 2, it'll be negative 3. And at time 3, it'll be negative 1. And at time 4, it'll be positive 1. And at time 5, you're going to be positive 3. And at time 6, because we're adding 1 second onto this, and every second your velocity changes by 2. This will be positive 5. And at time 7, positive 7. So your location, okay, your location here starts at 0. From 0 to 1, your velocity was averages negative 6. So we have to, your location will be negative 6. Here from 1 to 2, your average was negative 4. So this will be negative 10. Add negative 4 onto this. This will be negative 2, this average here. So it'll be negative 12. This average here is 0, so it'll still be negative 12. This one will be an average of 2, so add 2 to this will be positive, negative 10, so add 2 to it. Sorry, negative 10. For this 1 second, the average here was 4. Add 4 onto this will be negative 6. And this average here is 6. It'll be back to 0. So in fact, after 7 seconds, you're back to where you began because your displacement is 0. Your location is 0. So this object is moving negative 6, and then a negative 4, and then a 2, and then it goes around and comes back at that location, and then goes 4 and back, and you're back to your begin after 7 seconds. So there's my 7 arrows, and we wanted to know, in fact, at what time are we here? At what time are we at negative 10? And we're at 2 locations, 2 times we're at negative 10, 2 and 5. So we didn't really need to do the formulas here. We could have tried to do it visually, and because these numbers are nice, we could have done it visually and found out that the location that you're at is negative 10 twice. Okay? And at the midway point, between at 3.5 seconds is probably where we're going to be furthest away. And that'll be right at that point here. So you're moving away, and that's when you stop. Your velocity here in between will be 0. Okay? Dun, da, da, da. That's a little bit more of a visual with the chart. Anyways, thanks very much. Subscribe, like the question, leave your comments down below, and see you next class.